Okay, so in this video, we're going to talk about circles, which is the first conic section that your students are going to learn about in Algebra 2. Okay, so talking about the standard form, x minus a squared plus y minus k squared equals r squared. R is obviously your radius. Okay, h and k, right, is a standard form of notation for vertex and or center, depending on what kind of conic section it is. In circles, the h and k is the center. Okay. So as an example, let's say we have x minus 2 squared plus y plus 3 squared equals 36. Okay. So we can pull our h and k out of this. Our h is going to be 2. And our k is going to be -3. Note that they change signs, okay? Because it's minus minus, the signs will always be opposite. And our r here is 6. Now, if we wanted to graph that, that's a pretty simple process now that it's in standard form. So we go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Obviously, this is easier with graph paper. So we start at our center, which is 2, -3. Make our mark for h and k. Okay, and then we just count 6 units in every direction, all of our cardinal directions. 10. So we go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we're going to estimate that 3, 4, 5, 6. Okay, and you connect the dots as best as you can. Obviously, this is more of an egg or a small potato than a circle, but that actually is normal. Even if this had been done on graph paper, honestly, it probably would not have come out much better. Free drawing conic sections rarely works out that neatly. All right, and that's pretty much it. Circles are very simple. They're very easy to work with, which is pretty nice. Let's see. An example here. Now, the one thing you really need to be aware of is when your circle's equation is not in standard form. And so if they give you something like x squared plus y squared plus 10x minus 4y plus 21 equals 0. Okay, well, I can tell if this is a circle just by looking at it, because my x and y are both squared, they're both positive, and they have the same coefficient. It's 1. That's going to be a circle. Okay? But I couldn't graph it this way. I have to put it in standard form. And this is one of our applications of CTS, complete the square. I talked about it in a previous video. All right? These kinds of problems have to be solved using completing the square. And it's really not that difficult, so we'll do this one pretty quickly. First thing we're going to do is we're going to group our terms with like variables. So I'm going to say x squared plus 10x, and put that in parentheses with a little extra space. And then it's going to be y squared minus 4y, also in parentheses. And I'm going to subtract that 21 to the other side, skipping straight to the first step of CTS, moving that constant. Now, since we have no leading coefficient in here, it's a 1, we go straight to divide and square. So I'm going to rewrite my 10 and divide it by 2. And then I square, giving me 25, which I'm going to add right here, and to the opposite side of the equation. And I repeat the process with my y. So I take that 4 and divide it by 2. I square it and get 4, which is convenient, and I add that 4 there, and to the opposite side. So these are both perfect trinomial squares. So we can rewrite those right away. Bring down your first term, your first sign, and the square root of your last number. First term, first sign, square root of our last number. And over here, we're going to add all these together and get 8. Okay. So we can see that our h and k is -5 and 2, and our radius is square root of 8. All right, that's a common mistake. A lot of students will get to this step and say, oh, that's my radius. My radius is 8. Now, standard form is r squared. So if it's not squared, you have to take the square root of it. Square root of 8 is obviously going to be awkward to graph. That's pretty normal. Your graphs are really just estimates. So long as you can look at it and more or less know what you're looking at it, that's really all you need. And that's pretty much it. Circles are nice and easy. One last thing, and this only comes up in a couple of problems in Algebra 2. I haven't seen it in any of the classes yet, but who knows? And I might as well mention this here. Let's say this was like so, but instead of being an equal sign, what if it was less than or equal to? How would that change the graph? Well, it's an inequality. You know you're going to have to shade it. So we mark our center first, right there, and then we would count out our radius in every direction. Square root of 8 is less than 3, so 1, 2, and a little less. 1, 2, and a little less. Okay, now we're going to get a rough estimate. It's less than or equal to, which means it is a solid line, but less than in a circle is inside the circle. So our shading would actually be inside. And just like in a regular inequality, if it was not equal to, it would be a dashed line. So just bear that in mind. It doesn't come up very often in the conic section of the book, but it does occasionally come up. Just remember that if it's less than in a conic section, really regardless of the conic section, if it's less than, you shade inside the shape. If it's greater than, you shade the outside of the shape. And that's it. That's circles.